The Mercedes-Benz W123 is one of the most iconic cars ever built. Decades later, it still fascinates enthusiasts around the world. This classic model holds secrets that few people truly know about. In this video, we'll explore what makes the W123 so legendary. The Mercedes-Benz W123 was designed under the leadership of Bruno Sacco, a chief stylist known for his focus on proportional harmony and functional aesthetics. Sacco's approach rejected short-lived design trends, emphasizing instead clarity, balance, and engineering honesty. The W123's body lines were clean and symmetrical, with a wide stance, upright grille, and precisely measured overhangs that projected solidity and refinement. Each curve and surface was tested for aerodynamic efficiency, reducing wind noise and improving stability at high speeds. The headlamp cluster, chrome detailing, and beltline trim followed geometric precision to visually lower the car and enhance road presence. Sacco also refined panel gaps, ensuring consistent tolerances for better sealing and long-term durability. The design was developed to be timeless, appealing in both form and function even decades later. Unlike competitors that relied on decorative styling, the W123's design communicated structural integrity and restraint. This disciplined philosophy became the foundation for Mercedes-Benz design language well into the 1990s, making the W123 one of the most enduring automotive shapes ever created. The Mercedes-Benz OM6117 engine was a 5-cylinder, 3.0-liter diesel designed for maximum longevity and minimal maintenance. It used a cast-iron block and head, a forged steel crankshaft, and oversized connecting rods, creating a structure capable of handling immense internal pressure. The indirect injection system delivered cleaner combustion and allowed smoother cold starts compared to earlier diesel designs. A mechanical Bosch inline fuel pump precisely metered fuel delivery without relying on any electronic control units, making it ideal for export markets with limited repair infrastructure. The engine's large oil capacity, deep sump design, and robust cooling system kept temperatures stable during long-distance and high-load operation. Dual fuel filters ensured clean diesel flow, while gear-driven components replaced belts to eliminate common wear failures. The suspension system of the Mercedes-Benz W123 was a masterpiece of mechanical precision, designed to balance comfort, stability, and endurance far beyond normal expectations. Instead of simply softening the ride, Mercedes engineers built a suspension capable of absorbing years of punishment while maintaining precise road handling. The front setup used double wishbones with coil springs and a stabilizer bar, giving the car exceptional control during cornering and braking. At the rear, independent semi-trailing arms ensured that each wheel moved separately, keeping the ride smooth even on uneven terrain. High-quality rubber bushings, forged control arms, and gas-filled shock absorbers minimized vibrations and body roll, creating the signature magic carpet feel that made the W123 famous. The entire system was designed for longevity. Components were metal-reinforced and could handle hundreds of thousands of kilometers without major wear. This suspension wasn't built for luxury alone. It was engineered for survival on the worst roads imaginable, which is why W123s still glide confidently decades after leaving the factory floor. One of the most ingenious features of the W123 was its vacuum-powered central locking system, a quiet and reliable innovation that set it apart from every other car of its time. Instead of relying on electric motors, Mercedes used a network of air pressure lines, diaphragms, and vacuum pods to lock or unlock all doors, the trunk, and even the fuel flap simultaneously. When the driver turned the key, the vacuum pump sent air through these sealed lines, activating the locks in perfect synchronization, completely silently. This system was not only futuristic in the 1970s, but also incredibly durable. Because it used no electrical contacts or motors, it was immune to water damage, short circuits, and corrosion. Even if the car sat unused for weeks, the system could hold vacuum pressure long enough to function perfectly. The W123 earned its legendary reputation on the roads of Europe, Africa, and the Middle East, not in luxury garages, but in the hands of taxi drivers who demanded reliability above all else. From the streets of Berlin and Athens to the heat of Cairo and Khartoum, the W123 became the universal workhorse of professional drivers. Its OM6117 diesel engine, simple mechanical systems, and sturdy suspension were designed to survive abuse, long idling hours, and rough terrain without complaint. Taxi fleets quickly discovered that the W123 could cover hundreds of thousands of kilometers with minimal maintenance. Parts were interchangeable, easy to repair, and available worldwide, creating a global network of mechanics familiar with the car. It wasn't unusual to see W123 taxis still running after 30 or 40 years, often with their original engines. The Mercedes-Benz W123 was not just a car. It was a global machine, engineered to thrive from the frozen Arctic to the burning deserts of Africa. Mercedes developed special tropical and Arctic versions tailored for extreme climates. The tropical models featured larger radiators, extra cooling fans, and improved ventilation systems to withstand relentless desert heat, dusty environments, and poor fuel quality. Meanwhile, the Arctic versions were equipped with powerful heaters, double insulation, thicker oils, and reinforced electrical systems for effortless cold starts in sub-zero temperatures. Even small details were adjusted, like carburetor tuning, battery capacity, and fuel line insulation, to match the weather demands of each region. These versions weren't marketing gimmicks. They were built by engineers who studied local conditions and adapted every component accordingly. The W123's cooling system was a prime example of Mercedes-Benz's obsession with durability. Every component was designed with excess capacity to ensure the engine stayed at optimal temperature under any condition, from German autobahns to African deserts. The radiator featured large surface area fins and thick copper cores for superior heat dissipation, while the thermostat precisely regulated coolant flow to maintain stable engine temperature even during steep climbs or prolonged idling. A viscous fan clutch automatically adjusted fan speed based on heat levels, reducing drag when cooling wasn't needed and maximizing airflow during high-load situations. The water pump, made of cast metal instead of plastic, circulated coolant efficiently through reinforced hoses and corrosion-resistant passages. In tropical and Middle Eastern versions, an additional auxiliary fan and larger radiator were installed to handle extreme climates. This system's reliability ensured that overheating, a common issue in lesser cars of the era, was virtually eliminated in the Mercedes-Benz W123.